Good day, everyone. You are welcome back to Class Bridge. Now, very quickly today, we are going to learn how to solve this exponential equation step by step. Very good. So, how do we solve this exponential equation? The first thing we need to do is to move this left-hand side to the right-hand side. And when we move it to the right-hand side, you remember that their sign will change. So it means we'll be having 100 raised power x minus 10 raised power x minus 1 raised power x equal to 0. That's the first step. So the second step is changing this 100 to 10 raised power 2x minus 10 raised power x minus. Now, you see that we have 1 raised power x here, but we know that mathematically, when we have 1 raised power any number, the answer is still the same as 1. Take, for example, when we have 1 raised power 100, is still the same thing as 1. 1 raised power 1 million is still 1. So instead of us writing 1 raised power x here, we just keep it as 1 equal to 0. Now, what do we do next? You can observe that here we are having the same base here, but the power of this 10 here is twice the power of this 10 here. And whenever we have a situation like this, what we do is we substitute. We use the substitution method. So what do we say? We can now say let P be equals to 10 raised power x. And if we say P should be equal to 10 raised power x, it implies that P squared will be equals to 10 raised power 2x. It means that whenever I see 10 raised power x, I replace it by P. And whenever I see 10 raised power 2x, I replace it by P squared. So, rewriting this equation, it will become P squared minus P minus 1 is equals to 0. Now, we see that what we have now is a typical quadratic equation, and it is not factorizable. So whenever we have a typical quadratic equation that is not factorizable, what do? We use the quadratic formula, which will be P equals minus B plus or minus the square root of B squared minus 4AC over 2A. Right? Very good. We can now say where A is the coefficient of P squared, and the coefficient of P squared is 1. B is the coefficient of P, and the coefficient of P here is minus 1. C is a constant, and the constant we have here is also minus 1. So we can now substitute those values in our quadratic equation, and it will become P equals minus 1 plus or minus the square root of minus 1 squared minus 1 minus 1 over 2 into brackets 1. And when we simplify this correctly, we have P equals minus times minus is 1 plus or minus the square root of 1 plus 4 over 2. And when we simplify, we have P to be equal to 1 plus or minus the square root of 5 over 2. Now, we already know that whenever we are solving quadratic equation, their answer always come in pairs, right? So we have it to be P equals 1 plus the square root of 5 over 2, or 1 minus the square root of 5 over 2. And when we simplify each of them, we have this one right here. We have this one to be 1.618. When we simplify this correctly also, or we have it to be minus 0.618. Please, you can confirm that. Now, we can now recall that we said it earlier that 10 raised power x should be equals to p. Whenever we have a situation like this, we need to use logarithm. And if you look at the values of p's that we have, one is positive, one is negative. And we already know that we can't find the logarithm of a negative number. So we just need to stick to our value of the positive number, which is 1.618. So which means that I can now have my 10 raised power x to be equals to, what's the value of p? 10 raised power x is equals to 1.618. So we now introduce logarithm. When we introduce logarithm, it becomes x log 10 base 10 is equal to log 1.618 base 10. Remember, in the laws of logarithm, whenever we have log a base a, it is usually equals to 1. So here we have log 10 base 10, so it is automatically 1. So we have x into 1 equals to, when we find the logarithm of 1.618, is going to give us 0.209. So the value of x we are looking for is 0.209. And we can confirm if our answer is actually correct. So for us to confirm, let me erase this place. So for us to confirm, we have said the value of x is 0.209. We just have to plug it in into this equation here if it will actually give us 0. So it's implied that we'll be having 100 raised power x, which is what, 0.209, minus 10 raised power 0.209 minus 1. Will it give us 0? When we evaluate this, it's going to give us 2.618 minus, when we evaluate this, it's going to give us 1.618 minus 1 equals 0. You can see here we'll be having 2.618. When we evaluate this, minus 1.618 minus 1 is going to give us minus 2.618, and is indeed equals to 0, which is correct. And that is it. So thank you very much. Till we meet again in our next class, stay mathematically active.